Today we'll be starting with a version control system called Git. Yesterday we had a demo and an overview, right? Wherein we were talking about a high level or a big picture of this CI/CD pipeline, right? And here if you see it's a chain or integration of different tools. And the first one is a version control system like Git, right? We will be zooming into each part and we'll proceed. So we are getting into this first tool, which is Git, and then we'll proceed further. So let's get into this version control system, Git. So there might be people who are completely new to this, or else people who are working on it, experience with the version control systems. But I'll be proceeding assuming everyone is new, like from basics till the advanced concepts. So let's begin with the version control system. What is a version control system? Why do we need it? Why do we need a version control system? Anyone? Anyone want to share your thoughts, your inputs? What is a version control system?
To control the different versions of the codes. Coding.
Any more answers?
Track the changes.
See, version control system, to understand this, let's take up a simple scenario. Okay, let's say there is some shared folder or shared drive, whatever it is, where they have all the project work kept in here. Right, there were multiple people working on it. Let's say there is a file called file1. Okay, there is a file1 and multiple people are working on this file. Let's say person A and person B. Both of them want to modify the same file. So they got this file to their local computer. They downloaded this file to their local computer, made their changes, and person A kept this file back to the remote location. Like he put this file back on Monday. Person B is going to place his file on Tuesday. So after person B making the changes, like everyone updating their changes on this file on remote, will have which person changes? Here I'm talking about without using any version control system. This file will have which person changes?
Tuesday person changes.
Obviously, after Tuesday, it will have only person B changes, right? Means what is happening? Person B changes are overriding person A changes, right? So he doesn't know that. B doesn't know he's doing it. Even A doesn't know that his changes are being overwritten. This happens if we don't use any version control system. Imagine there were 10 people in the team. If this kind of mess up happens, at some point, project will go corrupted, correct? So how to avoid this scenario? Yeah, that's where version control comes in. Means it's one of the things what a version control system does. Means it allows people working simultaneously on the same files. There might be a group of people or a team who needs to work on the same file, right? So it should not override any changes as a person. Like if anyone is working on the files, they would be concentrating on their logic, functional requirements. They cannot just sit and monitor if their changes are being overwritten or they were safe or not, correct? So this kind of thing should be taken care by a tool called version control system, right? It's one of the tasks which a version control system does. By the way, who uses this version control system? Developers, it's mandatory. Even testers use this, even DevOps teams uses this. Any configuration files, any static files, one can be version controlled. Let's say developers, they have some program files like Java, .NET, C Sharp, Perl, Python, whatever it is. Any files can be version controlled. Even test automation engineers, they'll have automation test scripts written as per the automation tool they use. Even they should be version controlled. Ops teams, they have their config files, scripts, even they should be version controlled. As a DevOps person, you develop some configuration files, manifest files for Terraform, Kubernetes, and so on. Even all of those should be version controlled. So basically, any static file can be version controlled. And I would say this is mandatory for anyone in IT. You may not become a DevOps person, but still you need to learn it, right? So first we will learn version control system for the perspective of managing your files. Second perspective is to implement it in the CI/CD, right? So both perspectives we should learn. First, I'm talking about using it to manage your files, manage your code base. Are we good? Yeah, first thing is it allows people work simultaneously. Second thing, let's suppose something, let's say application is working fine till 7 a.m. Something went wrong and application crashed at 7:15. Something went wrong and it's not working fine. You want to immediately revert it so that the business doesn't come down. So meaning you should know what happened during this 15 minutes. Means you need to have a detailed history of person may made changes to file 1 on line number 9 at 7:05, so that led to this crash or whatever. Right? This kind of detailed logging. Can anyone do this manually? Right? You have a lot of things to take care. You can't just work on these things. That's where again version control system comes in, which provides you with this kind of detailed logging, which can be helpful at the time of disasters or at the need where you have to recover the things. Correct? And what else? Let's suppose you're working on file 1. You made this as a version 1. Client came with modifications on the same file. They asked to make a version 2. Let's suppose you have edited the previous version and made this one. Let's say after 6 months, client want to go back to the previous version. That wouldn't be possible, right? Because you have overwritten that. So don't overreturn the things. Maintain the backups, maintain the versions. That's again taken care by this version control system. It can help you maintain the backups, maintain the versions, right? So these are all the things which a version control system can take care of. Right? So when you have so many files, to secure them properly, to save them properly, to allow overwriting by the multiple people working on the same file at the same time, and to know what is happening onto which file at what time, a detailed logging, all these are possible through version control systems. I believe I made the things clear. Yes? So that's what a version control system is. And yeah, depending on the architecture, they were categorized as centralized version control systems and distributed version control systems based on their architecture. Now, coming to the centralized version control system, if you see this, a centralized version control system, as the name says, it will have a centralized or central remote repository. This is called the central repository or remote repository, where all the project work is shared or kept, right? And then these working copies are nothing but the workstations of individual users or collaborators, right? One sec, there's a problem sharing this. Okay. So this is the central server or remote repository. And these are the workstations of individual users. They'll connect to this remote and then make the changes, right? This is the centralized version control system architecture, which is very simple. There were some drawbacks or challenges with this kind of architecture. The main drawback is you always need to have network connectivity, right? For some reasons, if there is no network connection, entire work is halted because everyone is working by connecting to the remote or the central server, right? So that's one thing. Second thing, it works like the central server or remote repository works like a single source of truth. If for some reasons this central server is crashed or lost, entire changes will be lost, right? Means chances of recovery are very less. These are the few drawbacks of centralized version control system. And what are all the tools comes under this category? SVN, TFS, Perforce comes under the centralized version control systems, right? So these challenges of version control systems can be overcome by distributed version control systems. Let's proceed.
Can I ask something? What is SVN, TFS, and
Different version control systems, like you have Git, these are all different version control systems. There are many version control systems. These are some of them. But like I said yesterday, Git is very widely used. And for all the modern DevOps project, Git is preferred. So we are learning Git. These were all similar tools under the same category. Right, good to go?
Preeti, I have one doubt.
Hmm.
For example, if in case of any network issues, we resolve the network issues for the DevOps engineer, or else as network team, they will resolve it.
We will not do anything here. A network issue is about the connectivity to the server. We have nothing to do here. There will be network teams, separate teams. I'm talking about the architecture of the repository here. When you have network issues, you may feel you may not be able to connect to remote server and the work may be halted. Got it, right?
Yes, yes.
So to overcome these drawbacks, you have got distributed version control systems, right? So if you see the architecture of distributed version control system, again, there is a central server. Okay, this is the central server or the remote server where all the project work is. And this is the workstation of individual developer or collaborator or DevOps person, whoever you call it. If you consider DevOps team, he is a DevOps person. Or else if you are considering development team, each developer. These are the workstations of individual developers. And so this is, let's say this is my workstation. I'm having again my own repository, which is called local repository. In distributed version control system, they will have a central server. Okay, this is the central server or remote repository. And every user will have their own workstation, which is called, their own copy, which is called local repository, which is a copy of remote. Okay, what is the use of it? It is like they don't directly work on the central server, and also they will not directly work on local. They'll work on some directory and then move their changes to the local repo. And from local repo, their changes goes to central server or remote. Likewise, every user will have a copy of remote repo, which is called their own local repository. And they will not directly make changes on this local repository. Okay, they'll make changes on a working directory or working copy, then move their changes to local, from local to remote. This is called Git tree. It is like 3 steps before your changes goes to remote. Unless your changes goes to remote, they are confined only for yourself. Means if your changes are in local repo means only you can see those changes. No one else can visualize those changes. They are confined only for yourself. Right? So this is how it is. And here if you notice, majority of the works happen on the local repo. Local repo means on the same laptop or same workstation, means it's hardly accessing the hard disk. That's all, right? So majority of the work happens here. Once the complete work is done, you push your changes to remote or get the changes from remote to have a copy. So these changes, these push and pull are less frequent when compared to changes on local, right? So majority of the times you work on local, so obviously it is quite faster, right? Because you have to access just your hard disk, right? And also network connectivity, let's suppose network is disconnected. You can still work on local. You need network connectivity only during push or pull, which are less frequent. Am I correct? Got the point, everyone? So this distributed version control systems are way faster. Even though network connectivity is not there, entire work is not halted. You can still work on local repos. And then what else? Yeah, also let's suppose, okay, central server or remote repository is lost. Chances of recovery are more. Right? Chance of recovery are more. You can recover because everyone is having a copy of it. Chance of recovery are more. These are all the advantages of centralized version control systems. Advantages of distributed version control system over centralized. And Git comes under this category. Git is a distributed version control system. Git, Mercurial, Fossils comes under this distributed architecture. Again, out of this, Git is more preferred and more widely used, particularly in the modern DevOps projects. Git falls under this distributed version control architecture. Any questions on this architecture from anyone? Are we clear?
So SVN is centralized, right? Not a distributed one.
Yes, centralized.
Hi, Preeti. Previously, I think SVN is the one most used, right? Before the distributed one.
Before Git SVN is used, but now Git is very widely used than any other tool.
Hi Preeti, Lex is a centralized or
Which
distributed? Lex.
Lex? Can you spell it out?
LEX.
LEX. I don't have idea on it.
Achha.
So these are the distributed version control systems. And like I said, there were many version control systems. And if you see this graph, okay, this is from 2020 Google Trend Report. You can also check the latest graph. Okay, here if you see, Git is clearly the winner in the category. Even till date, Git is the winner. When you compare it with SVN, TFS, Fossils, see here, there is no equal or good competitor, or this is as per the market usage. So Git is so widely used. The blue graph is Git. So that's the reason we are learning Git. Of course, when you know Git, working with other tools would be similar. Analogy would be similar. Concept would be similar. So switching it is not a big deal.
So Git is having both, right? Free and paid.
Yes. Now coming to the Git architecture. We have learned the architecture of distributed version control system, right? Here is the architecture of Git in particular. Like if you see this is the, okay. So this is the architecture of Git, and here if you see local repo, this is actually the workstation which I'm talking about, and this is a remote repository. So users can copy from remote and create a local. Again, like I said, you cannot make changes directly on local repo. Rather, you will be working on another directory. If you are a Windows person, directory is nothing but a folder. You work on a separate folder or a directory. Then you have to move your changes to staging area. Staging area is like a virtual layer. It's a virtual layer. This is called index area. First, you have to move your changes to staging. Then you have to move your changes to local. You cannot straight away move your changes to local. Means you cannot do this. You cannot directly move your changes this way. This is not possible. First, you have to move your changes to staging area. From staging area to local. That's what it's like a 3 steps before your changes goes to remote. What are the commands to do this? We will learn it separately. I'm trying to explain you the concept. So first, your changes will be in working directory. From working directory, you have to move your changes to local. From working directory, you have to move your changes to staging. From staging, you have to move your changes to local repo. That's like a 3 steps before your changes goes on. Like I told you, staging area is a virtual layer, a virtual layer, which is also called as index area. What is the importance of it? Why should we have this virtual layer or index area? It works like a preview or else pre-check before your changes goes to remote. Right? This is like a preview or else pre-check before your changes goes to remote. Right? Meaning to be more specific, let's suppose you have 10 files in your working directory. Okay, you want to place only 5 files in your local. You will add only those 5 files to stage. Means in short, I can say, this helps you to have better control on your changes, how your changes are moving, like what changes you want to move to local. And then from local, what changes should go to remote. It helps you to have a better control. See, whatever we were discussing now, I'm going to show you those things practically in few minutes. Okay, so just understand the concept, and we are going to see them practically in some time today. So that's the how this is going to work, like the architecture, Git tree. This is called Git tree. And also, this is called Git tree. Your changes moves from working directory to staging area, from staging to local, and from local to remote. Right? This is how changes moves on. And let me tell you an interesting thing here. Local repository, when you talk about local repository, this can be created in two ways, means two use cases you have, right? The first use case is like, you can create a, let's assume you joined a project. Okay, it's a running project already. It's a 4-year-old project. You joined it today. Already remote repo is there. Like a lot of changes were there. You can copy from remote and create a local repo. That's one method. And create a local repo. This is one use case. Or the second use case is, let's say it's a new project. A team is formed now. It's a completely new project. You need to create your Kubernetes manifest files and so on. So what you will do, you will create an empty local repository because there's nothing on remote. You create an empty local repository, develop or create the files here. Okay, make changes here, and then push to remote and create a remote repo. That's a second use case. Those are the two use cases how your local repository can be created. We will look into both of them. Were the use cases clear?
Preeti, I have question here. So, firstly, I was a little bit confused here because when you said that we are having the first copy from the remote, okay, so from server, remote is just like server, you are saying, right? So, in this flow, what is happening that from, say, from server, when we are going to have a copy, so, you know, it will be from server to then staging and then local repo, right? I did not get this working directly. How does this fit in this particular flow? Because the flow should be from remote, because remote is what you are saying, that server, right? So from server, if we have to copy the local, then from remote we have to copy to staging area, and then from there it will be local repo, right?
Staging
Preeti?
area is not the environments. I think you are messing up this with the environments. This is not staging environment, develop environment. These are not those things. This is the architecture of Git. Okay, and this is your local workstation. This
So
is
when you say local workstation, what does it mean?
your local
Because you are saying
your laptop.
local laptop, right? So remote repo is your server, right?
One second. This is your local machine. This is your laptop. Okay. So this is somewhere on the remote, some server. So you are getting a copy from remote. Let's say you joined a project. It's already having some remote repository. So you create local repo.
Okay, so directly pull, right?
Yellow box. You are getting a
Hmm.
Now you want to make changes. You cannot directly make changes on local repo. What you will do, you will make changes on some directory called working directory, then move them to staging area, from staging area to this local repo. And then from local again to remote if you want to share it with others.
Okay, so any change if we want to make, firstly from local copy, we will push it in the working area, working directory.
No, not from local repo. From working directory, you start making your changes.
Okay, so from working directory to virtual staging area, and then from staging area it will push to remote area from local repo, through local repo, right? Preeti? But
Correct. From
one
local
question.
repo, staging area to local repo, from local repo to remote.
Yeah, but this particular box, thick box which you are saying local, here the yellow one, that local repo, this is where you are pulling the Git all the files, right? So how this is moving to this working directory? That is my question, because right now you have files on the local repo only. That local repo is totally local, means I did not get it how this
How
file.
it will move, we will see with the hands-on. Okay, we are going to do hands-on. How a local repo changes or how you move from working directory to local. We will discuss that. Just understand the flow here. Okay, you
Okay.
are getting a copy from remote to local. Okay,
Mhm.
local is where which is a copy of remote. If you want to make any changes, first you should make changes on working directory. From working directory to you have to push to staging. From staging to local. Again, from local to remote, if you want to share them with others. How this happens, I'll show you. Okay, before going to those things, I'm talking about few things which you need to have an idea on.
Okay, and for centralized, because I was speaking, I think my speaker was not working, functioning. So when you talked about centralized, was that the case that we are not maintaining any local version there? Because when you said that, we are just going to have a server, and then we will have the local, users who will check in and check out. So they are also maintaining this local copy, right, Preeti?
They will
In
not
that,
maintain a local copy. Directly, they'll make changes here and push to remote. Only like maintaining a local copy in a sense, they'll just get the changes, make the changes, push it back. There is no kind of working directory, staging area, local repo. And that's not been an exact copy of remote. Whichever files they want, they'll get those files, make changes and push it back. It's not an exact copy of remote.
okay, okay, Preeti.
So here we are talking about two use cases of creating local repository. To reiterate the things I'm repeating here, you can create a copy from remote and create a local. All right, that's one thing where you already have remote repo. Let's say it's a new project, you don't have remote. So you create an empty local repository, develop your changes, and then again you can push to remote. These are the two use cases. And before I go any further, let me explain you another very interesting thing. Here I'm talking about working directories, staging area, local repos. Imagine them like a different folders. But the very interesting thing here is this working directory, this local repository are one and the same. Means it's the same folder or same directory. If you are a Windows or Linux person, same folder or directory. Then how come you say working directory and local repo? Physically, they are same. Logically, they are different. What does it mean? This should answer many of your questions. Logically, they are different. Meaning, let's assume, okay, this is a local repo. I created a copy from remote. That's a folder. Okay, local repo is a folder. Now in this folder, if you just created a file or copied a file from somewhere means this file is said to be in the working directory only. Okay, after creating, if you run this git add that file, then it is said to be in the staging area. Then later on, if you commit those changes, it goes to local. That's why then they are said to be in local. Means basically those three are same folder, right? Physically same folder. Logically, that's how they are different. Now it answers your question, I believe, some of you who asked earlier.
Yes, yes. So it means that firstly it will come to the working directory. From working directory to add git adding in the git, move it to the staging area, and then from there to git commit to
It's
local
all the
repo.
same folder. By the end of the day, it's the same folder. You created a copy from remote to local. The same folder is nothing but local repository. Same folder is nothing but the working directory. But
Yes, Preeti, I got it.
yeah. So if you just created, okay, already some code base is there, already you have copied. That is all in local repo. But let's say you created new file. That is said to be in working directory. Again, if you physically see, it's in the same local repo. Local repo, working directory, or physically one and the same folder. But logically, this is how they are different. Means they overlap. Just imagine I have drawn 3 boxes. Just you keep them overlapped. Right? Am I making sense?
But as we said in the example, from the working directory to local repo, initially we have 10 files, right? So staging area, we moved only 5 files. So when you say both are same, but here in this case, it is different, right?
Then you will say 5 files are in staging. 5 files are not in working directory. It is always with respect to your files, with respect to your changes. Let's say here I created 10 files. 10 files are set to be in the working directory now. Let's say I have added 5. Now 5 files are in staging area, 5 are in working directory. Okay. Then let's say I commit those files. Then those 5 files are in local repo. So this is the theoretical part or the concept. Now let us see this practically. Good to go? To visualize whatever we were discussing now, let's see this practically. Any questions before we move on? All right. So now let's go and install Git. First, Git works on all the operating system. Git works on Windows, Linux, Mac. So Git works on any operating system. That's the first thing. So you may use Git on Windows, Linux. See, only installation differs. The concepts, the Git commands remain same. So I'm going to use Git on my laptop itself. Like it might be on Mac or Windows or Linux, whatever it is. You can just install Git directly on your laptop and use it. So how to install Git? Git installation. You have the official website gitscm.com. Here are where you have different operating systems, how to download. If it is Windows, you download the executable, the installer, and run the installer. A simple way of doing it. Let's say you need help for this. You have the drive, like I have already, like whoever registered will be shared with this. I think you already got access. Here is the drive. Okay, even those installation steps, because mine is not Windows, so I have all the screenshots added in Git installation on Windows. See here, you have all the steps. It is very simple. You don't need these steps also, but still in case if you need any help, you have all the steps documented, including the screenshots, right? So this is how you can go with. Okay, this is one thing. Git installation on Windows and how to use it, everything there. Let's suppose you want to do it on Linux. It's very simple. If you just go to Linux here, you have the commands to do it. Minstall or whatever. Okay, just one command will do. And if it is Mac, again, it's just a one command, brew install git. That's it. You open the terminal and run the command on Mac. Only, like I'm again repeating, installation steps differ. That's it. Once it is installed, everything else would be the same. So I'm going to do it on my Mac. This is my Mac. Okay, I already have got Git installed, so I can run Git version. Okay, Git is installed. Perfect. Git is installed on my system. Similarly, you can have it on your own. Like you can do the installation on your system. Now, okay, Git is installed. I would like to prefer the second use case first. First use case we'll do later. Second use case is, let's say assume it's a new project. Okay, there's a new project, new team. So nothing on remote. We want to create a local repo and then develop here. Later on, we'll push to remote. So I'm taking up this use case. Okay. So now, okay, I want to keep all my project work in some folder. Let's create some project folder. Let's say my project. Go to that. Oh, by the way, if you are using a Mac, these are simple Linux commands. mkdir means creating directory. Or else if you are not comfortable with the CLI, you can use the GUI. No problem. Okay, you can just go here, right click, create a folder. This way you can do. I'm just creating a folder. Okay, if you are not comfortable with the CLI, use the GUI in Windows or in Mac or wherever you want, right? Okay, Linux will learn it separately, but I'm just using some simple Linux commands. mkdir means make directory or make project. This is another way to create a directory from the CLI. And I want to go into that directory, my project. So I'm inside my project. PWD, present working directory. It will show you in which directory you are in. If you are comfortable with the CLI, with the basic commands as such, Linux commands, you can do this, or else you can do from GUI also perfectly fine. Are we good? Anyone, any difficulty in understanding the CLI or anything? Should I proceed, or can I have a quick confirmation from all the participants?
Yeah, we can proceed.
Good to
But
go?
Preeti, if you can show the GUI also
Oh.
partly, because I'm not very comfortable on the Linux part. So if you can just show the directory part, that will be
Yeah.
easy to visualize.
Okay. MKDIR, my project means it created it. CD, my project means it went inside this. Okay. So parallelly, I will show this, right? Now, LS means from CLI, how do you see that? I want to see all the files and folders. So LS. In GUI, how do you see? You just double click, go there and see that. It's empty anyway. Are we good now? This way?
Yeah, Preeti.
Right. Thank you. So, yeah, now there is nothing here. Okay, fine. But I decided to keep all my project files in this folder. So, means like I want to make this a local repository, right? Means I want to tell Git to version control all the files in this folder. I want to tell Git to track to version control all the files in this folder or directory. Means this is my local repo. This is how you create local repo. So go to the folder wherever you want to keep your project files, whichever you want to get version controlled, and run the command called git init. Git init means in whichever folder you are running git init, I'm running in this folder, means this folder will become a local repository. Means this is how you create a local repository, an empty local repository. Later on, I'll add the files here, right? So git init will create a local repository, will make that particular folder a local repository, and also it will keep on tracking whatever files present in this folder. See, when you do git init, it says initialize empty git repository. Okay, and you can see all the hidden files. .git is there. Means that's an indication. Whichever folder having .git means it's a local repository. And any files you are going to add here will be version controlled, will be tracked by Git. Okay, so okay, fine. Let's see. Let's create some file. How do you create a file? In the GUI part, you may just go here. Yeah. You may just go here, right click and create a new folder, new file this way. Or else from the CLI, if you want, there is a touch command. Touch file one. I'm just creating a text file.
No,
It's
so Preeti, when you say init git,
just
git
let
init,
me finish the render. Let me complete my statement and you can ask your question.
okay.
That file name will create a file, right? This is a command which will create a file for you. That's again a Linux command, very basic Linux command. If you are not comfortable, you just go here, right click and create a file. Okay. So I'm just creating a file and you can create any file. It could be a text file, or if you are into development, you can create some Java files, any programming files, or some script files, as shell script files, anything, whatever you want. Here, our interest is not to work on the files or the content. Here, we are learning Git to manage the code base, to manage our files. So I'm just creating some simple text file. It's an empty text file. If you do ls, you will see that here. Here also in your folder, you should see this now. Yeah, do you see that? So if you want, you double click, there is nothing in here. You can, you know how to edit a text files, right? Or if you want to do from CLI, echo command is like a print command. It will print whatever you have. Now, the same thing, I want to put it in the file one. You can use this redirection arrow. See, all these Linux commands will be taught separately. Parallelly, I'm showing you both the ways of how to do it from CLI and the GUI. So that will add this high text into this file. You can check this way, open the file. See here, right? That's like an editor, like you are editing the file, you are making some content there. If you want to open the file here from CLI cat, okay, if you are not into Linux, ignore this, do it from GUI, that's perfectly fine. So now I have one file. So whether Git is tracking or not, what Git is doing, we'll see. Before that, yes, can you please go ahead with your question, Dhirender?
When you say that init git, right? So what that command, from the GUI side, if you don't want to use this
You
Linux
don't have
command
a
or
GUI. Git commands should be run from CLI only. You have Git GUI, but if you learn, you have to install Git GUI separately. Okay, if you learn GUI, you will never learn the commands and the concepts. CLI should be always preferable, and Git commands should be run from CLI only. Otherwise, you have to install GUI separately. That will not work for you to learn the concepts. So go with CLI only for Git commands.
okay.
So, okay, fine, I have one file. Sometime back I'm talking this, my project is a local repository. So what is happening with the file if you want to know? Git status. Git status command tells you just come here. Untracked file means Git know there is a file, but Git is not tracking it. What is Git telling? It's giving you a clue to add. And sometime back I told you, this is nothing but your local repo. This is nothing but your working directory as well. Correct? And now can you tell me where is this file? Always compare it with respect to the architectural diagram. Always compare this with the architectural diagram.
Indirectly.
So it is saying to add, it is asking us to add, means where is the file?
Working directory.
Working directory.
Everyone, is that clear? So yes, it's in the working directory. But you said it's a local repo. Yes, this is local repo, this is working directory, but logically they're different. When I just have created a file, it is in working directory. Untracked file means, yes, it's in the working directory. So if I want to move to staging, what I should do? Git add file name. Then again check the status. Where is the file now? Can you tell me where is the file now?
Stage.
I want to listen answers from everyone of you. If you are in the class,
Staging.
please do respond. It is in the staging area, correct? It gives you clue as well. Changes to be committed means not yet committed. Not yet committed means where are they? In the staging area. You should always refer to this architectural diagram. This architectural diagram should be there in the back of your mind whenever you are doing this. So what should I do now?
Commit the code.
Commit minus M. M flag is mandatory. M means message. Some a message which later on can help you understand what this commit is doing. That's user defined. You can give any name. Done. Now if you check the status, see it's clean. Clean means whatever files are here were there in local repo. Where is file 1 now?
Local repo.
Staging area.
Local repo after committing. If you just created a file, we call it is in the staging working directory, then add it, then we call it in staging area, then you commit, then it is in local repo. But it is in the same folder physically. That's what I'm talking some time back. Physically, it's one and the same folder. Logically, this is how it's different. Are we clear? What we discussed some time back theoretically, are you seeing this practically there?
Yes.
Yes.
Right? Let's repeat it with
When we use
another
the Git
file.
command,
Let's
when we
repeat.
use the Git command, one second. So when we use the Git commit command, we don't need to mention any files, right? So what all the files in the staging area, all
Whatever in the staging area will be committed when you don't mention the file. That's a best practice. But if you want to commit only specific files, you can mention the file name, but we rarely do it. Whatever in the staging area will be committed when you run the commit command. Acknowledge if it is clear. Got it clear?
yes.
All right, now let me repeat it with another file. So how do you create a file? You go here, right click and create the file. Okay, but I would prefer this way. Touch, so that I'll also get used to Linux slowly. Just creating a file, that's it. Okay, create a file and I would like to put some content. Print command, this is a print command. I'm not bothered about the content, some dummy contents. double arrows or redirection arrows, which will add to the file whichever you want. Okay. If you want to see the file, I don't think, yeah, see another file is created. 1 minute. Let me remove this file too. Okay, file 2.txt is there. Okay, done. Okay, fine. Now, where is this file to? Can anyone help me out? LS will list the files in the folder. So where is
Staging
this
area.
file?
It's
Staging
in
area.
working directory.
Working directory.
Working directly.
I just created the file. Okay.
Working.
LS will list the files in the folder. There is another command, git ls files. Git ls files will list the files in staging area and local repo. See, file 2 is not there. Got it now? Right? There are many ways to check where the file is. One way is this way. Another way is git status. Git status tells you untracked. File 2 is not tracked because you have to add it. So where is file 2 now?
File 2 is in working directory.
Working directory.
Directory. What we should do to put it in staging area?
Add.
Git
Add file. Now if you do git ls files, yes, it is shown there, as well as git status tells you changes to be committed. Means where is the file and what should I do?
Staging area.
What should we do now?
We need to commit the
Local
local
repo.
changes.
Minesium, let's say something like second file, some message. Done. And if you do ls, okay, 2 files are there. And git ls files, please keep muted everyone. So file 1, file 2 are there. Right? Everything is good. And if you do status, it's clean. Got it right, everyone? So that's about this.
Preeti,
Now
Preeti,
you relate to this architectural diagram. Whatever we were talking about few minutes back, it makes more sense. Yes, please.
This git ls command is showing the files in the working directory, right?
Staging area and local repo.
Staging area and local. Okay.
Files in the staging area and local repo. Right? Now this architecture should make more sense for you. Okay. And another thing is you have to remember Git works with respect to changes. Okay, not with respect to files or folders. What I mean by that? Git works with respect to changes means your change might be creating a new file. Your change might be modifying a file. Your change might be deleting a file. Everything is same. Meaning, okay, till now we created new files. Shall we modify the existing files? Isn't it? It's not about always you create new file, correct? You may have to modify. So let's say I want to modify this file 1. I'm using an editor called Vim editor. Vim is an editor. Okay, like you have Notepad as an editor. Notepad++ is an editor, correct? Vim is an editor for Linux environment. Vim, VI, these are all different editors. Are you getting me?
Yes, but Preeti, tell me one thing. To edit any file, right now the files are moved to the local, right? So now to move or to edit any file, it has to go back again to working area, working directory, and then from there we will again push it to local, right? Or we can, because right now you have pushed both the files in the
One
local.
second. I'm going to explain the same here. That's what I started with. Okay, just done this. If not, your question is answered, you put your query. That's what I'm going to show. To edit, you need an editor, right? So I'm talking about editor now. So Vim is an editor in Linux. VI is another editor. Nano. These are different kind of editors in Linux. Again, you'll have a separate learning on this. Okay, you can just have some idea. These are different Linux editors. In Windows, you may use Notepad, you may use Notepad++, or whatever you are comfortable with. You can use Word document, you can use anything. Here, we can use any editors as such. And in real time, like as we go by as a DevOps person, you'll be working with Kubernetes manifest files, Terraform config files, correct? Even developers, let's say developers are learning this. They'll be using some Java, they'll be writing some Java programs, .NET programs, C#, Perl, Python, and so on. So there should be a good editor for them, right? So that it should help us with the syntax, a better visibility. So one such better or best editor is Visual Studio Code Editor. I want to modify the file, so I'm looking for some editor. See, we'll be learning anything as per the requirement, not just because to cover the content. So now I need to edit the files. Let's talk about the editor. Just got stuck up here. 1 minute. Okay. Yeah. So just go to Google and type in. There were so many editors. VS Code editor is very widely used. You can use IntelliJ or any other editors if you are aware of. VS Code editor is one very widely used editors. Like in the interviews, they will also look for some hands-on or like your experience with the editors so that it helps them understand whether you have worked with these tools extensively with these files or not. So VS Code editor, if you type in, you'll be taken to the official website. It's just simple, like a notepad, you can download this one. See here, you can download depending on your operating system. See, download it for Mac or Windows or Linux. It's as simple as that. So download it from here and launch it. That's it. So this is the editor. This is that VS Code editor. Okay, which helps you edit your files more conveniently. That's all. So how do you edit? Go to file, open your project. What is our folder name? What is our Git project? What is the name?
My project.
My project, right? So open that folder in this editor. See, you will see all the files. You can double click. See, it's very easy to edit this way, isn't it? Yeah, it's very easy to edit this way. So I can edit this way. And also, like I'm using this terminal, right? If it is Windows, you will use Git bash. Like that's what you call the terminal. You can launch it in this editor itself. See, go to terminal. You can launch your terminal here itself. No need of a separate window. Making sense, everyone? See, right? You don't need another separate window. These are all advantages of it. Also, if you create some Java files or whatever, it will help in identifying or highlighting your syntax. Certain features are there. So get used to this editor. This is just like a notepad or something like that. All right. Now coming back, we created new files till now. Shall we modify them? Yeah, let's modify this. It's very easy to modify here. I'm just removing this unnecessary line. Okay, even that is a modification, right? So save it. Now when you do git status, what it will do?
How do we save this?
Control S. Like you save any other files. Okay, once you make change and save it, it is saying changes not staged. It's not telling you untracked, but unstaged. What is the difference between untracked and unstaged?
Tracked is a new file and unstaged is there was a changes been made.
Is already added in the staging directory.
Untracked is like for the first time for a new file, you will see like untracked message. Unstaged is like file is already added into staging area, but some modifications to the file. That's it. And where is untracked file?
Working area.
Working directory.
Correct. Where is unstaged change?
Working.
Also in working directory only. Only that particular change is unstaged, right? So if it is untracked, what you should do? Git add, git commit separately. For unstaged, you can do it separately. Same. Or else you can do it in a single command with the -am. -a means add and commit. You can do this. Right? If it is unstaged, you can do it separately this way. Clear, everyone?
Yeah, Preeti.
So if it is unstaged, you can do with a single line or separately. But for untracked, you have to do it separate commands only. That is the point you have to make a note of. Okay, now it is unstaged. I can do git add, git commit separately, or else I can just do with a single command. I'll do with a single command because we didn't try out on this. -am and let's say file modification. Right now again the same thing. Right, means what is happening here? Whether it is a new file or modification, first it will be there in the working directory. You have to add it and you have to commit. Right? That's what I mean. Git works with respect to changes. Your change need not necessarily be always creating a file. It could be modification as well. Whether it is a modification or whether it is a new file, it should be added and committed. And the difference between untracked and unstaged changes. Are we clear till this much, everyone? Any questions,
Yes.
confusion?
Preeti, can you show me like a file one when we create now first one?
This is file one.
No. Previously when we started like a file creation, then I will show you. I'm making directory of file one.
History command.
Yes,
you list
yes,
of the
like
commands. It is gone here.
Ah.
mkdir will create.
yes. So before that, we need to create a one new folder in the desktop. Yeah, like a file1.txt. When we modified, for example, in case any kind of text we changes, so it will be affected that folder only, like any another folder it will be created.
See, wherever your file is there, that will be modified, right? How come another folder will be modified? See, don't make the things complex and confusing. It's same like how you work in any other folders. Like if in your system, if there is any folder, if you make modifications to this folder, only this folder, this file will be affected, right? Or will anything else be affected? Yeah. I'm asking you, will it affect any other folder or directory?
Another file I'm telling to you.
You're talking about like if you modify your files, let's say this is our project. If you modify this file, you are saying will it affect any other folder? Is that your question? If you change these files,
the file 2, file 1 also will get affected or not?
if you modify file 2, file 1 also get affected. Is that your question?
No. Actually, my question is, actually, I need to create a one folder in my project name, like a folder name is project. So I need to create a one file like a file1.txt. I wrote something like a welcome to something for this session. So in Git, I need to changes like a modification. For example, what you told, echo something that.
Print it and place it in that file.
Pardon?
Print command. Echo is a print command.
Yes.
Okay?
Oh,
And output of it I'm placing into this file. Those are Linux stuff. You are not comfortable with it, you edit this way. You just open the file and edit in VS Code. That's fine, right? You don't need those things.
Okay. So this is for Linux V code. So what about Windows?
Which is for Linux?
This one is V code for editor, any modification changes.
Concepts are same, whether it is Linux or Windows, concepts are same. How do you edit your files differs. This VS Code editor is available for all operating systems.
Okay. Thank you.
Hi, Preeti. I just have one doubt. Like, as you have said that git commit -am and message command will move the file. It will operate two commands, add and commit. So why it is not used for the untracked files when we use it first time?
For untracked files, you have to add first, and this unstaged file means it's already added, right? It's in the staging area already, isn't it? File is in the staging area, only modification is there in the working directory, right? File is already there in staging area and local. In that case, only the modification should be added and committed. In that case, you can do this way. If it is
Yes,
not there, file is not at all there, you can't do this way. You have to do separately only.
yes. So it is that command will also do the two things like git add and git commit.
But it is different for if the file is not at all there, you have to do separately only.
Yes. Okay, thank you.
Any more?
Preeti, one question. Since most of the users will have Windows only machine, because I don't know how many will be having your Mac. In next courses also, do we have any kind of differences in terms of tags and all those things which you are going to show in the Mac? It will have different, like
Commands
you
will
said.
not be different. Here and there, small differences will be there. Wherever there is a difference, I'll let you know and I'll point out the differences. Not that everyone is having Windows. Many people are there with Mac. And also, as we progress, we'll not be using Mac at all. We'll not be using our local laptop. We'll be using AWS machines. Just Git works on any system. It should be convenient for you to make any changes over. So I'm showing it on local system. Everything will be on AWS servers.
Okay, one question, Preeti here. See, first time when we have any project, and suppose I am new developer, I join a project. So, and already one project is running. Okay, so when we install Git, there should be one kind of configuration to establish the connection between that server and here in the local, right? Then only we can just copy a file or do whatever it is. But that first time establishment between that your server, project server, which is currently running, and the local server, which actually go for a particular developer, need that establishment, right? Connection establishment. Then only the exchange of file and the commit all will happen, right, Preeti?
Correct?
So where we are doing this actually means you said that we install the Git. Okay, first time we install the Git. Now this folder creation and everything is happening in the local file. But suppose if we have to establish that connection, do we have to mention it in our first time after installing the Git? We will have to establish that connection as well, Preeti.
We will be doing it. Okay, we have a separate topic on that. We are going to learn all those things.
Okay, okay.
There were many things we have to do before we go there. Don't jump on, okay? Don't jump on, hop up onto the next topics, please.
I think he is mistaken, yeah, because initially that this topic is for creating a new repository.
Local
Just a
repo.
few, yeah, just a completely
We are
new.
not yet
It
connected.
is not existing project we
We
are
are
working.
talking about the first use case. Please listen, concentrate on listening. I'll be there here definitely to clarify all the questions. Don't hop on. We took a second scenario here. Second scenario is assuming that there's nothing on remote. Why are you talking about remote? There's nothing on remote. I told you it's a new project. We are all joined the new team. It's a new project. We created a local repo, empty local repo with Git in it. There's nothing on remote. There were so many things we have to do before we go to and connect to remote. Okay, we were going to look into all those concepts, right? I definitely understand you might be curious or anxious to know those things, but jumping on, hopping on will not work. Okay, we are covering those things. Like I already told you, 2 use cases I will cover. Okay, you can also check the course content, what are all the things we are covering. But yeah, hope you got an idea. We will do that. Okay, how
Okay,
and
Preeti.
how I'll show you.
Okay.
So before you go to remote or connect to remote, there were so many things you have to learn here. Okay, and then we will go to that remote. You see this architectural diagram. Let me point out here. We were still on this local repo, yellow box. There is nothing, no remote for us because we are on new project. We don't have this at all. We were at this point only. Local repo, the first use case. Okay, we have to do many things here. You have to learn how to delete the files, how to delete the files in multiple ways. You have to learn how to revert, how to rebase, how to reset, how to stash. So many things, how to do merge branches, merge with conflicts, without conflicts, how multiple people will work on it. All of them we will learn, then we'll talk about remote. Until then, we don't have remote at all. Then we will see how to push to remote, how to copy from remote, how to connect to remote, and so on. Okay, just this is a flow so that you know what are all the things will be going, how we'll proceed. Let me gist out those things as well for much better clarity. Okay, these are all the things we'll be going to look in. Git deleting the files, okay? Git reverting, git reset, git ignore, git rebase, git stash, git branching. Again, there were huge topics, okay? Git merge with conflicts, without conflicts, where multiple people work on same file. Like I told you in today's description, how the changes will be overwritten and all, how this Git avoids that. Also how Git performs logging, okay? And then stashing, rebase, ignore, done. I might have missed some of them. Then comes the remote. Okay, maybe 2 more days before you go to remote. Then connecting to remote, cloning, pushing. And one more thing, one last command I would like to show you today. As you are working on this architectural diagram, actually today we were just on the basics, trying to understand the architecture, correct? What is this repository, like what is Git repos and all, I mean, staging area, working directory. And there is a command called git log. Git log will give you the complete commit history, right? See here, every commit, till now I made 3 commits, means I have run 3 times commit command. Every commit will generate this alphanumeric, that's called hash code, which is unique, right? So every commit will have this. And this is the history, including the author name, some email ID, the date, including the timestamp when the change was made, right? This is helpful in tracking and reverting certain changes. If you want to see the brief log, brief commit history, git log 1 line. See, it is first 7 characters are enough. First 7 characters, you don't need the entire ID. And the commit message. Commit message is like after 6 months, if I see, it should give me some sense. Okay, it's about first file in the repo. Like, let's say we're working on Terraform changes. Okay, this Terraform is for creating EC2 instance. Some comment which makes you sense to understand what these changes are all about. Got it? So that's the log command, and we have many things to do with the log. So do the hands-on on whatever we have done, understand the things thoroughly. Everything will fall in place as we go by, and all the necessary things, required things, everything will be covered. Okay. And I would like to tell you one more thing. We were running this command, right? Okay, this is a different history. You are running this commit command, correct? For the first time, like whenever you are committing your repository or else on your system, for the first time on your system, if you are doing this, it will ask for username and password, username and email ID. It means for tracking, like see, when I see the log, see, it's showing me the name and the email. Some kind of tracking it need to register, right? So before committing for the first time on the system, this is not my first time, right? I have used this Git many times on my laptop. So it's not asking me. For you, whenever you are committing this command, means whenever you're running this, it will ask you to register your email ID. These are the commands you have to run. It will give you clue there. Okay, don't worry. It will give you these commands in the clue. Global username, some username you have to put. Similarly, user email, some email ID. Those it will give you in the clue when you are committing for the first time, run those commands. That's for registering your commands with some name and email ID. Any more questions? Are we clear with the architectural diagram and working directory, staging area and local repository? Are we good with that part? That's what is today's agenda, the basic architectural understanding, creating this folder.
So, Preeti, I just want to say one thing. So, I think it would be better if can you show us a single folder which is not a Git local repository and a folder which is Git repository, and just show us the hidden files into both folders.
Hidden files in the,
Yeah,
okay,
in a Git repository folder and the
this is
any
Git
other folder.
repository, right? This is Git repository. ls minus
Yeah.
show the hidden files. It will have .git. Normal folders, if you do ls minus a, you will not get .git, right? I don't think
Right.
I have normal folder.
So if you just create a folder and
Yeah, this is daily task. This is a normal folder. If I do ls minus a, where is .git?
yeah, yeah, that's why I just want to point out. Whenever we'll have a local Git repository, it should have a .git inside, so that make is Git repository, right?
You can check from your end as well. Yes, see, this is not having .git.
Yeah, and my second question is, are we going to will you cover Git cherry pick topic as well?
Git cherry pick will not be covered. It's not much to do with cherry pick. It's not a regular command, but I can
Yeah.
explain you what it is. You can try out on it.
Okay. Thank
It's not a regular command. We don't use it.
you. Yeah. Okay, thank you.
And Preeti, with Git, few keywords like GitHub and Git bucket is also I have heard. So means can you just tell us what is that GitHub or Git bucket, or are we going to cover this in next session as well?
Yes, GitHub will be covered. Bitbucket is similar to GitHub.
Okay.
GitHub is nothing but you're talking about remote repo, right? That's nothing but your GitHub. Bitbucket, GitHub, GitLab, these are all similar. If you know GitHub, Bitbucket is almost similar. Those work
Okay.
on the remote repos. We will be covering GitHub.
Okay.
All right, then recording will be posted in a couple of hours. In 1 or 2 hours, you will get the recording in the WhatsApp group. Okay, you can go through the drive with all the installation steps you need. Git installation is pretty simple. It's very straightforward. Also set up your VS Code editor. That's just nothing but an editor. That's it. Okay, don't worry about is this programming or not. That's an editor to edit any files. It's like a Notepad++. So just install that VS Code editor, install Git on your laptop directly and start working on it. Explore the things. Whatever we have done, go through the hands-on. And by the way, please don't leave, okay? We are not yet done. Every day you have to go through the quiz, which will help you recollect or register the things we have learned. I'm going to share you the link here. Whoever have not registered might not be having this link. So I'm sharing this link for you. Please go through this quiz. I'll also get the results so that I'll understand your how much you grasped. Okay. Hope you all got the link. In the Zoom chat, I have shared it in the Zoom chat. Please go through it and submit the quiz. I'll also see your results. You can also retake. It's in the quiz portal page. This is here on the quiz portal on your LMS. Whoever doesn't have access, I have shared it with you. This is the one. Go through it, and any more questions you can ask me.
I think it is asking to sign in.
Yeah, you have to sign in with the Gmail ID. And
Okay. Oh, because it's on portal. Okay.
So today, do we have any lab also, Preeti?
yes, do the same lab we discussed in the class. Once it is done on the LMS, you have the assignments, the basic assignments, you can also go through. I would suggest to do first all these setups and the basic understanding we'll do for today.
Okay, Preeti.
Any questions in the quiz, you can also post it in the WhatsApp group, or we can also discuss tomorrow. Or anything you have, you can ask me, or else we can wrap up today. I'll also get the results. Check your results, retrospect on the results, and retake them. You can retake the quiz. Okay, certain questions might be out of the content for you to explore and finish up. All right, then. Thanks, everyone. We'll meet tomorrow. Have a good day. Bye, everyone.